Hi, here's a little project I've been working on in the last few days, and what it is, it's an AM medium wave radio, and what's special about this is that it's done almost entirely in software. There is no FPGAs on here, there's no digital down conversion. This takes raw RF in on an on-chip ADC on the microcontroller, which is an LPC4370 from NXP, and it takes that and does all of the processing on it in cold hard software and presents the output to an amplifier. So let's see how it performs. Let's plug in the power.
IMification, as it were, of many Arab states,
So
making
this
them
is
more
a
amenable to measures recommended
local
by
talk radio
international
station.
institutions to open up their economies.
It's a local talk radio station, and to prove that it is actually working, this is the loop antenna, and if I move it around, it will null. And also, if I put it up against, see, I've got a fluorescent light here. There you go. So, as you can see, it does work, and that's, as I say, all done in software. The little board down here is a bolt-on which I had to do, which includes a bandpass filter made out of passive inductors and capacitors. Switch that off. Passive inductors and capacitors. And just here is an amplifier. And all this is a quite a cheap dual op-amp, and it's cascaded, and I'm using that to give about 40 dB of gain on medium wave. And the board here is an LPC Link 2. And that's the setup, and I'll just take you through a block diagram of how it works. So here's a basic diagram of the radio receiver, the medium wave receiver. We have a loop antenna here, and then there's this bandpass filter which is made out of inductors and capacitors, and it's passive, and it also has a 2K resistor, so it detunes the loop antenna, so it's doesn't resonate a particular frequency, so it broadbands it. But because we've done that, we need a little bit of amplification, so there's two op-amps here, and then that's fed into the ADC input of the LPC4370, samples at 2.04 megasamples a second, and then PWM out. The PWM is operating at 255 kilohertz, but the actual downsample rate here is just under 16 kilohertz. So that's the basic block diagram, and then below here I have the software and how that's set up. And I'll just zoom out a little bit here and move it down. So on this, what we have is we've got the ADC, which is read in using DMA, and 6 2K ping pong sample buffers, which just go around in a queue. The reason it's 6 of them is actually further on down the chain I do the mixing and demodulation in 4K word blocks, and unfortunately the DMA on this device has a maximum of 4095 rather than 4096 transfers, so I've done it as 2 lots of 2K, and I just have essentially look at this as 3 lots of 4K when it gets further down here. And then I've got a quadrature NCO. This is running in a floating point, and a quadrature mixer, which takes the RF input. Again, this is actually raw RF. This hasn't been down converted, and it produces 2.04 megasamples a second, and goes through an FIR filter, and is decimated by 128, which gives you your just under 16 kilosamples a second, and a demodulator, which is basically a modulus function, so it's a square root of the square of the I and the Q. And then out to the pulse width modulation. A couple of things here. To actually make this work fast enough, had to do an awful lot of optimization of these parts here. The quadrature NCO and mixer actually are integrated together, and it's done in assembly language. and the FIR filter and decimation is also done in a single step, rather than having to do the filter and then do the decimation. Again, that saves quite a bit of time, and this is actually using a polyphase filter to do this. If you try to do a standard FIR filter, 1024 taps with 2 megasamples a second, I'm afraid it's just not going to work. So I managed to save a bit of time here, but in fact pretty much 70% of the CPU is spent here doing this decimation filtering, and there's a further about 15% in here, which doesn't leave you very much left to do the demodulation. And yeah, this is from here onwards, this is all in floating point. The LPC4370 has got a floating point unit on it. I did consider doing it in fixed point, but I'm not actually sure you're going to make a lot of benefit doing it fixed point, and floating point makes life a little bit easier. So that's the setup for the AM receiver. Thanks for watching.